Hello there. My name is Arka Prabha Chaudhary, and I'm currently studying in BVRIT CSE, and I'm from CSE A section, and my roll number is 521 A0521, and I'm excited to share my project today. And the project is about detecting fake news, and I've done this using various algorithms and compare their accuracies. And I would like to introduce myself a bit and talk about how I'm interested in the machine learning just for a while. I have done a research paper on machine learning and I have published it in a conference, international conference, and it was successfully published in the journal that I've done with my colleague Gagan Chandra. And so I have some expertise in machine learning. And I'm glad that I got this opportunity to work on the concept more and more through this workshop, and it was an amazing experience, and I hope it will I will learn more and more from it. So let's just start with the project. So as you can see here, I hope you can see my screen. Here, as you can see, I've made the project in Google Colab, and here's the first. I'll just go through the code now. And here, as you can see, I have given the input data set here, fake or real news.csv. Then let's just go through what we have imported as usual: NumPy, Pandas, Seaborn, Matplotlib. NumPy is for the mathematics, Pandas is for the dataset calculations, Seaborn is for graphs, proper graphs, interactive graphs, and Matplotlib is the basic version of the graphs. This is just for more warnings. String RE is for the string removal, as we'll see later. NLTKs, as we'll see that later too. Then TF-ID vectorizer, then train test split, decision tree, passive aggressive classifier, stop words, and so on. We'll just look into that further on. And as you can see, I've already run all this to just save the time. And I've read the dataset here in a single line of code. Then this is the read input file. Now let's start with the main process of data cleaning and wrangling. So this is the first step after obviously reading the data input. Now, this is the first step, as we all know that the data set always is in the form of a raw data and it's not complete and it cannot be called a complete information. So first we need to find out the problems with it, what issues does it have, and solve those issues first, just to make sure that the machine gets it properly. Now, let's just start with the duplicated values. As you can see, there are 225 duplicate values. So let's just drop those duplicate values. Then, as you can see, the duplicate values have been dropped. Then we find the null values, which are like the values don't exist. They are not zero. Please note that these values are not zero. They just don't exist at all in the table. So now let's just look at what is this null. As you can see, there are tons of values. And as you can see here, there's one issue where you can see there's this unnamed tables or columns, sorry, unnamed columns here, many of them, and over 140 of them, which are just unnecessary. As you can see, they're just null values. I think it's a CSV file problem. So first, let's just label. As you can see, the label is there. First, we'll just convert the real or fake format of it, the real or fake, to ones or zeros. As we all know that the machine learning data sets must be converted into a numbers first. We cannot just take them into strings. No machine learning data set can work on strings, as it is a computer science foundation that machine cannot work with letters, it works with numbers. So we have converted using the map function real to 1 and 0. Then data set, if we are just ignoring all these unnamed tables and we are just selecting title, text, and labels, which are the important ones. And as you can see here, we got the data and title, text, label. Data is equal to data dot drop na. And now, what is this part? Now, this drops all of the null values. Instead of filling the null values with empty spaces or mean, as this data set is short and it has only three columns, and so I couldn't find anything to fill it with. And if I'm filling it with empty space, it's just causing errors. So I just went ahead and dropped all the null values. Now let's just display the data, and as you can see, the label goes from real to fake to just zeros and ones. Now let's go to data analysis. Now, Here we'll analyze the data and see what's in it and what's not. So as you can see now is null, there are no null values now, and it's all perfectly fine. So we are done with that. Now let's just go to data.shape. This shows how many rows and columns are there, and data.unique. These are shows how many unique values are there. 6,000, 6,000, and two unique values. These are the unique values, real and fake, or actually now 0 and 1. Now head again and just basic information about it, and let's just come to the fun part, the visualization of the code. Now visualization of the data set. Sorry. Now let's just start with a basic plot of matplotlib, and as you can see here, this graph just show you a perfect example of why people don't use matplotlib much often now. As you can see here, this just shows that these two are equal. Yes, they might be equal, but it doesn't show that much data, and it's not just clear at all. Now, if we go further down using Plotly, I've imported a plot. We'll see that later. What is Plotly? And using SNS, which is the Seaborn, which is just a high-end version of Matplotlib, which focuses more on interactive diagrams. Now, as you can see, I have provided a pie chart, and as you can see, yeah, the bar graph is actually true, and it actually shows you 50% and 50% data. Now, okay, we are done with that, but still, it's not clear, very much clear. Like, is it really 50% data? So let's just go to a new bar graph, which is created by, as you can see here, Plotly, and this is the one of the highest ends, high ends graphic design or visualization tools that just shows you, which just has a high end interactive diagrams. And as you can see here, if I just hover over this, it will show me label is equal to 0 and count is equal to 3154. Whereas if I go here, which is the one, which is the real, and it shows me label is equal to 1, count 3161. So this, the one which is the real, is actually more than the fake. So here, as you can see, if I zoom in a bit, I don't know if you can see it, but as you can see here, this is a bit more than that. So if I'll just reset it here. So as you can see, that's the visualization done over there. So now we got that, which is more. And now let's just go to get data cleaning. Now this is a function made which just removes all the unnecessary symbols, links, hyperlinks, question marks, uh, spaces and everything else. It just removes that because we just want to focus on the words. We don't want to focus on unnecessary data because that will just uh, waste the time of the machine and train it on waste data. So we'll just remove all of the data. As you can see here, it's just text is equal to re.sub. That re, as you can see at the top where we substitute it, just has this inbuilt function that removes all of it. We just give here what should be removed, and on the right hand side, what it should be replaced with. We are replacing it with null values, and where it should go, that which is the text value, obviously. Now this is the text value, and I've applied to title it too. So text and title. Now let's just start with the main part. We have taken x variable as the array of text, data text, and y is equal to label. So the prime logic of data science and machine learning is the one that is predicting, the one that has the training data, must not have the last predicting data, which is the label here, which is we are predicting whether the news is real or fake. Now, as you can see, we have taken y as label and x as text. So here, text does not have the fake part and the prediction part, and y has the prediction part. So what we're doing is we are calculating x to find out y. So that's pretty simple right there. And now comes the main part of this project, which is the TFIDF, which means term frequency inverse document frequency. It sounds complex, but in simple words, it basically converts the characters into numbers. But how does it do that? It just provides a number to the value of the word, like how important the word is. For example, if there are continuous words like the, and so on, there's it just gives them a waste value, like those are not important. But words which actually matter, for example, Donald Trump is dead. Here, Donald Trump and dead are the main words. So it focuses on that and provides them the higher value. And the machine automatically understands that, okay, this has a higher value, so let's give a higher importance to this. That's what TFIDF does. Now this, as you can see, we have used a vectorizer which creates an object of vectorizer, and the x dot shape again to just see what are the rows and columns. And then we just sort the values, and we create a data frame of sorts. As you can see, this is a long value, and here are the list of values. As you can see, it just mixed up everything into a small segments, like maybe he and so on. Now comes the data splitting, and we have used the inbuilt function train test split, which will split the capital X and Y. What is capital X? As we can see, we have converted, vectorized the small x to capital X, so it becomes the form of integers and numbers, and x and y, small y, and text size we have taken as 33%, and that is the test size, and train size obviously, which is minus of it, 67%. Now random state is a random value which is taken, which just shuffles the values. We can just change that anyhow we want. Now let's just go with the first algorithm that we've used, is the decision tree. Now, keep in mind, I have not been able to achieve the highest accuracy in this project, but I've tried my best and I've gone through all the algorithms, and I hope that this project is fruitful. Now, as you can see, first we have gone through the decision tree classifier, and we have tried use the classifier CLF here, and we have given the X-train and Y-train data, and we just provide the X-train and Y-train data first. We don't give the test data because we are focusing on the train data first, which has the primary values like title and text. So we give those values first, and then you just print the training accuracy with X-train and Y-train, and as usual, testing accuracy at X-test and Y-test. And as you can see here, testing training accuracy gives me 1.0, which actually is which actually is just 100%, and this is 0.60, which is 60%. 60% is fine, it's low, but it's fine. But 1.0 is not accessible. Sorry, it's not acceptable, as just means that this value is too high and it's just overfitting the data, and nothing can be 100% in machine learning. Machines are not perfect, hence we just skip this algorithm, and we see the confusion matrix here with the true negatives, true positives, false negatives, and false positives. I don't want to go get into that more. Let's just go through the next algorithm, which is a logistic regression. Now I'll just go through the algorithms once. Decision trees, basically it builds trees based on decisions, and it gives a final value with based on classification. Logistic regression will basically form a graph and will plot values according to it and form a logistic regression of sorts, and which will finally give you a value of classification here. This can be used for both regression and classification. And again, same X train and Y train. And what we've got in here is 99% and 62%. So yeah, that's pretty good considered with the previous results, because we got 99 and we didn't get 100, but it's still just a poor result still. Let's go with random forest again. Random forest is basically a bunch of decision trees taken together, and the final output is just average of those decision trees. And we have taken 10 decision trees here with estimators, and the criterion is entropy. There are various parameters such as Gini complex, entropy, and so on, and we have chosen entropy, and we've got the accuracy of 91% and 59%, which is still pretty low. So let's just go to support vector machine. Now this is quite interesting. We have used CVC, and kernel we have used linear. There are different kernels that we could use. I've used the linear one. And here you can see the accuracy is 99% and 63%, which is the highest one till date. So keep that in mind, please. And next we have used the KNN just in case. And I've seen KNN is basically it finds the distance between the points. And at the end, it just finds what is the closest neighbors and which category those highest closest neighbors falls into. If the closest neighbor falls into a category more, then it finally becomes that category itself. I hope that's understandable. And here you can see the rate accuracy is really bad. It's giving 50% both. So let's just ignore that. And therefore, as you can see, SVM gives the highest accuracy. Sorry, this is accuracy, not frequency. And now, as you can see, I have given a testing. This is really interesting part. I've given input text. So what this means is I've given the text Donald Trump is alive. This is the text, not the title. This is the text I've given, and this is provided to the machine learning algorithm, and it shows that yes, it is real, and based on the how we've trained it. So this is really interesting part, and this is extra feature that I've added actually. And now let's go see Donald Trump died, and it shows 0, which means it's false. So right now, even though it's at low accuracy, this example works perfectly fine. And here I've used one more XG boost just in case, And as you can see, training accuracy is 61 and 58%, and it does not work well.